I'm Anil Kumar, and in this video we will see how to sketch graph for tan of x where x, the angle, is given in radians, right? You need to complete this table and then sketch the graph for the tan function. Well, let it be tan theta or x, it doesn't matter. So the parameter here in the tables are used as theta. So theta has different angles here. These are the angles for which you really don't need a calculator. You can use special triangles and then apply the knowledge. That's what is tan theta. As you know, tan theta is opposite over adjacent side. So that is one thing you know. Second, tan theta could also be treated as sine theta over cos theta, right? So these things will help us to understand how the value of tan theta may change, right? To find the value of tan theta, we will use two special triangles. One of them is pi by 4, pi by 2, pi by 4, and the other one is pi by 3, pi by 6, and pi by 2 triangle. So these are the two triangles which we are going to use. In pi by 4 triangle, which is here, sides are 1, 1 square root 2 as you know. For pi by 3, pi by 6, triangle the sides are 1, 2 square root 3. So we'll use these two triangles to find the value of tan theta. I will also recommend you to look at sine graph and the cosine graph, right? So that will also help us to further investigate or understand tan function, since tan function is ratio of sine and cosine. The sine graph is kind of like this, and the cosine graph is kind of like this. So what I'm trying to say here is that for the sine function, we have zeros at 0, pi, and 2 pi. As far as the cosine function is concerned, we have zeros at pi by 2 and 3 pi by 2. So these are of our interest. These values will help us to fill this table very quickly, right? Let me show you how, right? So let's first look for zeros. Whenever numerator is 0, that is sine theta is 0, tan theta is going to be 0. Perfect. So tan theta is going to be 0 for 0, pi, and 2 pi. So let's write zeros for 0, pi, and 2 pi. Perfect. Now, whenever cosine theta is 0, tan theta will be undefined, right? Something divided by 0 is not defined. So those are the points at pi by 2 and 3 pi by 2. So we'll write here does not exist or undefined. Pi by 2 and 3 pi by 2. To start with, these are very critical and important values. Once we have filled these values, then we can look into our special triangles and fill the rest of the values. Pi by 6 means we are looking into this triangle, pi by 6, opposite over adjacent side, opposite over adjacent. So from pi by 6, opposite is 1, adjacent is square root 3, so you get 1 over square root 3. Pi by 4, opposite over adjacent is 1. Pi by 3, you look from here, opposite over adjacent, which is square root 3. Pi by 2. So once you do pi by 2, you are through with first quadrant. What I'm trying to say is kind of like this. Look here. That is what I'm trying to say. You have a quadrant plane where this angle is 0, this is pi, that is pi by 2, and this is 3 pi by 2. So, and you also know the cast rule, C-A-S-T. Now tan is positive in quadrant 1 and quadrant 3, is negative in 2 and 4. So as soon as you move away from pi by 2 towards pi, you are in quadrant 2 and tan value is negative. Do you get it? So now at this stage we are in quadrant 2. Tan value is negative. So let me put negative here for all of them. Similarly, when you land in quadrant 4, which will be after 3 pi by 2, the values will be negative. Do you understand? So now again we know when is tan negative, when is it positive. It is positive in quadrant 1 and 3, negative in quadrant 2 and 4. So now let's put the values. For pi by 3, acute angle is pi by 3, opposite square root 3, so we get square root 3 here. Pi by 4, 1, but with negative sign. Pi by 6, opposite is 1, square root 3, so we get 1 over square root 3. Got it. Now let's get back to 7 pi by 6. 7 pi by 6 comes after pi, right? So you are in quadrant 3, tan values are positive. So let's use differenting this time and then figure out all the values. 7 pi by 6, acute angle is pi by 6. Look at that triangle. 1 over square root 3. See how simple it is. Pi by 4, it is 1. Pi by 3 from here is square root 3 over 1. So I can write square root 3. 3 pi by 2, as we know, is undefined since cos theta is 0. Perfect. Now, when you move to the quadrant 4, all values are negative. Let's use the red color. Pi by 3 is my acute angle. Opposite is square root 3, so I get square root 3 here. 7 pi by 4, the value is 1. 11 pi by 6, 1 over square root 3. Quickly, you can get all these values. Do you see that? So that is how you get sine function. Now if you see the sine function, if you go from this side to that side, 0, 1 over square root 3, 0, minus 1 over square root 3, then 1 minus 1. So it's kind of minus of f of x. So what we see here is that tan is odd function. So tan theta or tan x is odd function, right? Since tan of minus theta is equals to minus tan theta. Do you see that part? So this is very important to observe. Second, what we note is, what is the time period for tan? It is not 2 pi. Time period for tan function is, when does it repeat? It is actually pi. See how. If you see 0, this, after pi again, 0, same values. Do you see? So the values repeat after pi, and therefore the time period for tan function is pi. So these are very critical values for you to understand. And now we'll get to the other characteristics of tan after sketching it. So let me sketch it here and leave some space for writing the key values. So what I will do here is, from these values I'll make a rough sketch. You do it on the graph paper, plotting all these values. As we saw here, that it has a time period of pi, and it does not exist for pi by 2. So let us say this is pi by 2 for us, and even for minus pi by 2 it will not exist, right? So it is minus pi by 2, like this. So basic function will kind of look like this. Okay, so, and it repeats after every pi. So it does not exist at 3 pi by 2. So let me write down here 3 pi by 2. Okay, and again it is 0. We found in between for pi. So let me sketch that function also for you. It will be kind of like this. Right, and then again it will follow, and this is 2 pi for us. So it is going from negative to 0 at 2 pi, so it will be kind of like this, right? So this is 2 pi. Anyway, let me write down these values and then we'll discuss further. So this is 0 for us, this is pi by 2, pi by 2, that one is pi, 3 pi by 2, 2 pi. So we have two tan functions. Do you see that? From here if you start 1 and then this is 1. Do you see that? That repeats. So after pi, the function 0 to pi, this is my function, which again repeats in 2 pi. So the time period is pi for the tan function. What else you notice? That here the domain is restricted. Domain for the function is x belongs to real numbers. I should have written theta, but x is not equal to these vertical asymptotes, which are at odd multiples of pi by 2. Do you see that? So we can write this as 2n plus 1 times pi by 2, where n belongs to integers. Correct? As far as the zeros are concerned, they are at n pi. And let me first write down the range. There is no restriction on range. So range for the function is y belongs to real numbers. Okay. Now zeros for the function are at n pi, where n belongs to integers. You also note that the function is always increasing in its interval, right? It is always increasing in its interval. The function is an odd function. I hope with this you know enough about tan function, and we'll explore more about it later. I'd like you to watch this video once again, understand all the characteristics, and do all these calculations on your own. Thank you and all the best.